Assalamualaikum to my lecturer and all my friends. My name is SUHADAH binti SALEHIN and my group members is Muhammad IMAN and Rahmat. So we are going to present about recyclable material classification by using convolutional neural network. For the introduction, solid waste is one of the problem in developing countries with an average of 1 kilogram of waste are produced per person in Delhi. Waste can be solid, liquid or gas and each type has different methods of disposal and management. Recycling helps minimize the amount of waste and using automatic classification machine of waste could further reduce labor cost of recycling tasks. Convolutional neural network was a vital technology to the waste sorter machine. CNN consists of input layer, hidden layers and output layer. And CNS is specialized type of neural network model designed for working with 2D image data. And it was proven that CNS is very effective in areas such as image recognition and classification. So in this assignment, we use CNN method to detect the PET bottle and aluminum can. So for the methodology, I will present about the convolution neural network. So CNN consists of input layer, hidden layer and output layer. In a hidden layer, it has 3 layers on it, which is convolutional layer, pooling layer and fully connected layer. In any feed-forward neural network, middle layer are called hidden because the input and output are masked by the activation function and final convolution. CNN feature categorization tag and input image and process it and group it under specific classes. CNN model is to prepare and test each of the feature, and it will go through a progression of convolution layer with channel kernel, fully connected layer and apply softmax function. So this is the architecture of CNN. So now I will start to demonstrate using Google Colab. So for the demonstration, firstly, we mount the Google Colab into our own drive. So second is feed the dataset directory. For the third step is create, train and validation data directory. So you can see when we run it, the can train length is 156, the PET bottle is 310, the length for can is 77, PET is 133, and the test name is the image of PET bottle and aluminum can that we are taken, which is 3. So for the fourth step is input the relevant library. So next is training the model, which is CNN. You can see there is convolution 2D, max pooling, flatten and lens. So for the max pooling is to reduce the dimension. So and then it will extract from input filter and the output max value of each channel. So for the flatten is to convert data to 1D array for input and to feed it to the next layer. For dense is a fully connected layer. Okay, next we will form the architecture and we can see the data for max pooling, flatten and dense. So after that is processing the input data. So the target size we set is 150 and the best size is 20. So at least we can see that the image are belonging to two classes. So next we train the process. In this training we use epoch value is 20. The step per epoch is 20 and epoch is 10. And for the validation step we use 1. So this is the data after we run it. So as we can see, the accuracy of training is all of them is 100%, and for the validation, uh, we can see that all of them is nearly to 100%. So this is the image in a graph. So the dot one is the training accuracy, and the line one is the validation. So this one is training and validation accuracy, and this one is for the loss. So before I proceed with the coding of the test image of the PET bottle and aluminum can, I will show the image that I take, which is for the first condition. The PET bottle and aluminum can is placed side by side, and for the second condition, the aluminum can is in the front, while the PET bottle is at the behind of the aluminum can, in 10 to 15 centimeter. And for the third condition, which is uh, opposite from the second image, which is the PET bottle is at the in front, while the aluminum can is at the back. So now I will show the coding for the testing for these three image. So for another task, for task one is to capture our own image for PET bottle and aluminum can. So for this task, firstly we put the PET bottle and aluminum can side by side. So after that, the image will be processed, and we can see that uh, the PET bottle and aluminum can is detected, and it's shown 100% for both of the object. For the second condition of the task is uh, put the PET bottle behind of the can for 10 to 15 centimeter. So we can see that the aluminum can is 100%, while the PET bottle is 0%. So for the last condition uh, is opposite from condition 2, which is the aluminum can is put behind of the PET bottle. So the result shown that the aluminum can is 0%, while the PET bottle is 100%. So we can conclude that the two different tasks for task one is successfully done by us, which is we obtain the graph for image that are obtained from drive. Um, so the second task is three different image of our own image of bottle and can. So now I will uh, So now I will let my friends to present the next method.
Welcome and good day to people who are currently watching. My name is Muhammad Iman bin ZAINUDIN. My metric number is AE170016. So today, I'm gonna explain about our assignment, which is the recyclable material classification by using convolutional neural network CNN. However, for my part, I will present a pre-trained network, which is the VGG16. Okay, as you can see on the screen, VGG16 is actually a 16 3x3 convolutional network stacked on top of each other in increasing depth. This model have 5 max pooling layer, which is used to reduce the volume size of the image. There are two main drawbacks from this system, which is it takes a lot of time to train, and the network architecture actually weighs a lot in terms of this volume. Okay. So as you can see on the screen, this is the model for the VGG16. There are 16 convolutional network and 5 max pooling. Okay, next we're gonna move to demonstration. Okay, as you can see on the screen, this is the coding that I've done for the VGG16 part. So from the first line, from Google Colab import drive mount, this is where we find the Google Drive rather than we download the file itself. So before that, all of these are using the Google Colab. And from the second line or the second column, we feed the dataset directory, which is the recycle file. You can find it in the Google Drive, your Google Drive file. Okay, recycle file, as I said. Okay, next, in this part, we set the pathway for the directory. In this case, we put train data in train, and we put the validation data in the validation. And last, just for confirming the information that we have, so we print the number of image per folder. As you can see, train image is 156, train length 300, pet bottle 310, validation for can 77, and validation for pet bottle is 133. Okay, next. This is where we input the TensorFlow. This line and this line is where we use the TensorFlow to set up the parameter. As I said earlier, the parameter for a convolutional network CNN we can custom it, but VGG is pre-trained model which using the already customized layer. So as I said, 16 layer, which is for VGG16, and there's VGG19, but that uses 19 convolutional layer. Okay, next. This is the model. We put another 2 layer, which is the flatten and dense. Both are used, the dense are used to the flatten. I mean, the first flatten are used to make the max pooling into one column, and the dense are used to connect it to the PC. After adding the 3 layer, and this is where we process the input data. Okay, next. This is where we the training process begin. As you can see on the data, which is epoch, which is the initialization, or we use iterate up to 10 iterate. As you can see, 1 to 10, and I already run it before because it takes so much time. As you can see, it takes 110 seconds for each one of them, with average of 95 seconds per one of them. So it takes a lot of time, so I run it earlier. And last but not least, we plot the outcome. First, the two main things that we plot on the first graph is the accuracy, and then the second one, which you can see in the line, is the validation accuracy. Okay, the bottom one is the training and validation loss for the training model. We go up for a little bit, and as you can see, as shown in the data below, as you can see on the screen, it shows the loss and the accuracy. So for this model, almost all of them are 100% accuracy. Okay, I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rahmat bin Buserah. My metric number is CE170097. Today I will present the recyclable material classification by using ResNet 50 convolution neural network. So here a little bit of introduction. ResNet 50 is a variant of ResNet model which has 48 convolution layer along with one max pool and one average pool layer. It has 3.8 times 10 to the power of 9 floating points operation and have 15 layers, able to train more than 1 million images from the ImageNet database. So this is the here is the model for the architecture of ResNet model. So it contain 50 layers for the total, and the first one is 7 times 7 convolution, and the second layer is 3 by 3 max pooling for the max pooling layer. Right, this is the image that will be tested in demonstration later on. The first image is can and bottle is at the same position, and the second image is the cat at the front and pet at the back, and then the pet is at the front and the cat is at the back. So the three type of image will be tested in ResNet 50 convolution. Okay, here is the demonstration of ResNet convolution in Google Colab. So step 1, I have mount the Google Drive with Google Colab, and step 2, fit data set factory, and step 3 is this is my path. So here is my path for the folder test, train and validation. This is the structure of the ResNet model. So the trainable parameter. So step 5 is pre-process the input from class, and then step 6, start training process. My approach value is this is the optimum value that I have tested. Step 20, step per approach is 4 and approach is 20. So the graph shows like this. So almost the result shows the optimal value is almost achieved. So the difference with validation accuracy is about 2 points. Okay. So for the accuracy training is optimum value compared to the test CNN test here. So the CNN test is more optimal because CNN value have we call the accurate approach number. So for ResNet they are a little bit different here because the validation accuracy is not in the training accuracy graph, training accuracy area here. So what can I conclude in this both training is the CNN training is more optimal value compared to the very resonate training. And then the resonate training is more time to run in it. So in order to train the fast training, CNN training is more faster and compatible. So that's all from me. Thank you.